Yes. With respect to the periodic table, in the last class we discussed about the ionization energy or ionization potential. Next one is electron affinity. Electron affinity. What do you mean by the electron affinity? Affinity towards an electron. In the ionization potential, the minimum amount of the energy is required to knock out the electron or to remove the electron from the neutral gaseous isolated state of an atom. For metals which are highly electropositive in nature, they have ability to give off an electron because they are good reducing agents. Then they have ability to give off an electron. Now, in electron affinity, we are adding an electron. For example, whenever chlorine in the form of the gaseous state. It is the amount of the energy released. Amount of the energy is required. This is amount of the energy is released. Therefore, ionization potential always an endothermic process because it requires energy. Electron affinity is always an exothermic process because it gives off energy. In ionization potential, delta H is positive. Delta H is positive means endothermic process. In electron affinity, delta H is equal to negative. Delta H is negative. That is exothermic process. But the amount of energy released is different. Amount of the energy released, that would be different. Whenever electron is added to the neutral gaseous isolated state of an atom, then it is converted into anion. In ionization potential, the end product would be cation. In electron affinity, the end product would be anion. Here Cl minus. Here delta H is equal to minus 481 kilojoules per mole. Minus 481 kilojoules per mole. Whereas energy released would be, if it is higher, then the amount of energy possessed by the species would be minimum. In such cases, the anions are more stable. Now, what do you mean by electron affinity? It is the amount of energy released whenever an electron is added to the neutral gaseous isolated state of an atom. Always anions are formed in this process. Therefore, what is the difference between in ionization potential, that is a characteristic for non-metals, characteristic of metal. Electron affinity, it is a characteristic of non-metal. Characteristic of non-metal. Non-metal means oxidizing agents. Metals means reducing agents. Reducing agents. Therefore, this is oxidizing agents and reducing agents. Now, it depends upon the various factors. Now, how it depends upon along the period and down the group. Along the period down the group. Whatever by along the period, atomic size decreases. Atomic size decreases. Atomic size decreases. Therefore, when atomic size decreases, electron has more affinity. Electron has more affinity towards the nucleus. More affinity towards the nucleus. Electron has more affinity towards the nucleus. Is it clear? Whenever it is very close to the nucleus, then the affinity force will be very high. Affinity means it attracts towards that of the nucleus. It indirectly implies that the nuclear force of attraction between the nuclear charge, that is the nucleus of an atom, and that of the added electron will be increased. In such cases, more amount of the energy will be released. More amount of the energy will be released. More amount of the energy. More amount of the energy will be released. Therefore, higher value of the delta, higher value of electron affinity, higher value of the electron affinity. Therefore, electron affinity increases along the period. This implies that electron affinity increases along the period. Electron affinity increases. Electron affinity increases along the period. Electron affinity increases along the period. Is it clear? This is very important. Why electron affinity increases along the period? In our board exam, they may ask, what is define electron affinity? How it varies along the period and down the group. Electron affinity is the amount of energy released during the addition of an electron to the neutral gaseous isolated state of an atom. Whenever the energy liberated will be more, anion is more stable because it acquires lesser amount of the energy. Down the group, down the group, down the group. Down the group, atomic size increases. Down the group, atomic size increases. Whenever the atomic size increases, what happens? Nuclear force of attraction between the nucleus. Nucleus force of attraction. Nucleus force of attraction. Nuclear force of attraction decreases. Nuclear force of attraction decreases, and hence electron affinity decreases. Electron affinity decreases. Electron affinity decreases. Is it clear? Therefore, electron affinity decreases down the group. 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 Therefore, exceptional cases are there. With respect to the halogen family elements, when you observe the fluorine, chlorine, bromine and iodine, usually the ionization potential electron affinity value of the fluorine is smaller than that of the chlorine. With the rest of the chlorine, like that of the bromine and iodine, the electron affinity value further decreases. Exception cases. According to this concept, fluorine that should possess the higher value of the electron affinity compared to the chlorine, but the electron affinity of the fluorine is smaller than that of the chlorine. Why this is due to? Why this is due to? Electron affinity of fluorine is smaller than chlorine. Electron affinity of fluorine is smaller than chlorine. Reason: due to smaller size of fluorine, repulsive forces are there between the added electron, repulsive forces. Reason: this is an electron in the fluorine atom and this is added electron. Because of this reason, due to smaller atomic size of the fluorine, whereas the added electron that exerts the repulsive force towards that of the outermost electron, because the outermost electron that has more affinity towards that of the nucleus due to very smaller distance. Therefore, very exceptional cases, the electron affinity of the fluorine is smaller than that of the chlorine. Then chlorine onwards, the electron affinity value decreases. This implies that electron affinity of bromine is smaller than that of chlorine. The electron affinity of iodine is smaller than that of the bromine. Therefore, electron affinity is in the order. Electron affinity is in the order. When it comprises of the fluorine, chlorine and bromine and iodine. Electron affinity of bromine is greater than iodine. Electron affinity of the bromine is greater than that of the iodine. Electron affinity of the chlorine is greater than that of the bromine. Electron affinity of the chlorine is greater than that of the fluorine. Or in the sense, this is about the trend in the electron affinity value. Among all halogen family elements, the chlorine have the higher value of the electronegativity. Therefore, the ion which is formed by means of the chlorine, that is a chloride ion, that is a more stable one. This is about the trend in the electron affinity values. Whereas in case of the zero group elements, they have the octet electronic configuration. Therefore, they does not have ability to attract the electrons. They have no ability to attract the electrons. Is it clear? Therefore, electron affinity value of the zero group element is always 0. This is about the trend of the electron affinity values. Is it clear? This is about the periodic table.